we'll survey around here. And then I'll switch us over to that Soyuz launch. That looks cool from up here. See, I already have oil infrastructure set up over here, and more importantly, I can scale it. We can make that train station longer so I can deal with a longer train. It might be better to just end up putting it over here anyway. I can move the refineries and stuff. Or we could just build out there, but there's that stupid evil rock in the way. There's a thing of uranium out there that I really can't move. I tried moving it before. Death happened. Nobelisks don't clear the rock? You want me to throw an explosive at a chunk of uranium? I mean, I'm not a nuclear physicist by any means, but I'm pretty sure that that's not that. I can't say how, but I don't think that's a good idea. But then again, who's to know if there's nuclear fallout programmed into the game? Who knows? You know what? We'll go Mythbusters on it when we get back. I am going to cover this Soyuz launch here. We're at T-minus 15 minutes and 30 seconds. And then we'll go from there. So I'll switch us back over to science and technology and we'll go from there. You know that a gram of uranium has 18 million calories? Oh, eating it's probably, probably really good for you. Talk about eating nutritious. Infinibulk. Alright. It'll fill you up for the rest of your life. Indeed. Hey, go suck with the freaking 8-month resub. Thank you. So the rocket's fully fueled here. T-minus 14 minutes. Oh yeah, Dan, it's set map. My pre-workout is a nanogram of uranium. Oh, Bandit. Bandit, no, bad. Yeah, Dan, it's old school. That's part of the reason why I like Satisfactory. It's old school. It's not a voxel-generated map. They specifically didn't do that, which is pretty neat. Yeah, pretty much 2020. Where's this launching from? Kourou, French Guiana. That's in South America? It's just north of Brazil on the coast. It's French territory down there. Uranium fever. Well, I had a talk with the AEC, and they gave some land for me to see. That's not the words. Oh, you mean the Russian, yeah. See, if it was a dynamically generated map, they could easily make drastic map changes. Yeah, but Coffee Stain's an independent studio, drummer. They don't have the money to do that. At least I think they don't. I mean, but also at the same time, if that's an easy thing to do, drummer, why aren't we making our own factory building game? Legalize recreational uranium. I'll take things that are not a good idea for 300. Is this where James Webb Space Telescope will launch? Not on this launch pad, Procyon, but a launch pad that's near this. Oh, I'm sorry, drummer. I didn't realize you didn't want to make money. That's fine. No, your anium. Aluminum, Dan. Aluminum. Aluminum? Goat Simulator made Coffee Stain billions. Yeah. Yeah. Here we go. The Roads to space. It's a funny word. Roads. The road to space.
Good evening. Good evening, everyone, and thank you for joining us tonight on Road to Space for Arianespace's 13th launch of the year. The mission was postponed due to unfavorable weather conditions last night, but for the moment I'm glad to say that the green panel is looking very green. So the Soyuz launcher will be taking off as planned in about 10 minutes' time. It is carrying on board tonight Galileo Fock M9, Sat 2728, the 27th and 28th satellites of the largest constellation ever built by the European Space Agency for the European Commission. The program, which aims to provide meter-level geolocation accuracy, has been in operation since 2016 and now has 2.3 billion users worldwide. I think at the moment we're just listening now to Joel El-Ghaghi, the CNES Director of Operations, better known by the acronym DDO, who's about to announce the start of the synchronized sequence. I'm sorry, yes, he has just announced it, thank you. So the two satellites on board tonight have been built by the European Space Agency, which unites the member states of the European Union, as well as Switzerland, Norway, and the United Kingdom. Joseph Ashbacher, who took over as Director General last spring, has great ambitions for space. And in an interview we did with him recently, he talks about ESA's involvement in this project, which will be coming up in on screens in the next 10 to 15 seconds.
Ladies and gentlemen, a launch from our European spaceport is always a very special moment, and I'm very delighted to be witnessing today the 11th operational Galileo launch in 10 years. Galileo is a truly European partnership that positioned Europe as a leader for satellite navigation systems. With two new Galileo satellites launched today, we are accelerating the completion of the fleet that now already has 26 satellites in orbit, with more launches to come in the following months and years until we reach the full constellation of 38 satellites. We developed and designed the Galileo system from scratch, and our commitment to technical excellence has helped Galileo become the world's most precise satellite navigation system globally, with more than 2.3 billion users around the globe. With such a large fleet and its complex ground segment, also developed by the European Space Agency, Galileo is a truly European success and a program ESA is very proud of. All of this could not be possible without the strong partnership around the EU space program, with the European Commission owning the program, ESA carrying out the design and development of the system, and the EUSPA operating it for the benefit of European citizens and society as a whole. And I would like to thank the European Union for the trust and strong relationship that has been built up and reinforced over the years. It is only 20 years ago that ESA introduced satellite navigation as a completely new activity in the European space sector. and it is our ambition and responsibility to maintain European leadership in the space navigation area. We are already working on the second generation of Galileo with state-of-the-art, more powerful and advanced and fully reconfigurable satellites. This will secure European satellite navigation for the future and allow Europe to remain at the forefront of technology with full autonomy in the satellite navigation sector. As ESA will bring first Europeans to the moon, and with new lunar exploration missions to come that will have a crucial navigation component, ESA and Europe are even to reach new frontiers in the next years. Enjoy this Galileo launch.
What space program is this guy paying attention to?
Of course, Galileo is one of Europe's flagship programs in the space sector. The satellites provide an alternative to America's GPS, which we all know, the Russians' GLONASS, or Chinese Beidou global satellite navigation systems. Now, the European Commissioner for Space, Thierry Breton, whose objective is to project Europe into the next technological race, talked to Rotospace about this ambitious program, which will ensure the European Union's autonomy in the field of geolocation. And we have an interview with him coming up now.
Aujourd'hui, nous passons une nouvelle étape dans le développement de Galileo, le système de positionnement par satellite européen. Dans quelques heures, en effet, nous mettrons sur orbite 2 nouveaux satellites, portant ainsi à 28 le nombre de satellites Galileo en orbite. Aujourd'hui encore, nous démontrons que l'Europe est une puissance spatiale. Galileo, bien que n'étant pas encore finalisé, est d'ores et déjà le meilleur système de positionnement par satellite au monde, plus précis que ses concurrents, notamment américains. C'est la preuve de l'excellence scientifique, industrielle et programmatique de l'Europe. Très concrètement, Galileo permet d'effectuer de manière autonome des missions aussi essentielles que variées. Navigation, aide au sauvetage, positionnement bien entendu, et bientôt aussi signaux cryptés pour utilisation militaire et de sécurité. Galileo est désormais à portée de main des citoyens européens, dans leur téléphone, leur tablette, leur voiture, et plus généralement tous les objets connectés. Car l'Europe spatiale est une réalité. Et nous en bénéficions tous les jours, sans du reste toujours nous rendre compte. Mais nous ne nous arrêtons pas là. L'Europe est déjà dotée d'un programme espace de plus de 16 milliards d'euros afin de rester une puissance spatiale. En particulier, nous avons accéléré la 2e génération de Galileo, qui est déjà en cours d'élaboration et qui sera un fleuron de la technologie européenne. Le programme d'observation de la Terre Copernicus, un autre pilier de notre programme spatial européen, fournit quant à lui, jour et nuit, des services et des images de très haute qualité, comme on l'a vu récemment lors des catastrophes naturelles qui nous ont frappés. Nous avons engagé une réflexion approfondie sur sa 2e génération. Nous travaillons à l'élaboration d'un nouveau projet de connectivité ultra sécurisé par satellite, permettant de fournir Internet à tout le monde en Europe et aussi d'assurer résilience et cryptage quantique des communications. Nous mettrons aussi en œuvre une approche européenne de gestion du trafic aérien, qu'on appelle le STM, et notamment pour assurer une surveillance autonome de l'Europe. L'espace est un secteur absolument vital pour l'économie européenne, et c'est ensemble, avec les entrepreneurs, que nous maintiendrons notre avance technologique. Nous pouvons et nous devons être fiers de ce qui a été accompli jusqu'ici, tous ensemble et à tous les niveaux. J'ai une pensée particulière pour toutes celles et tous ceux qui, au cœur des institutions et des agences européennes, ou au sein de nos partenaires comme l'Agence spatiale européenne, EUSPA, Arianespace, mais aussi les autres membres de l'industrie européenne active dans le domaine spatial, coopèrent au quotidien pour réaliser, construire, bâtir des projets tels que Galileo et en faire une réalité tangible. Merci donc à tous d'œuvrer au succès du programme spatial européen.
You could probably tell it. You shut up. You shut your mouth.
Well, the launch vehicle Soyuz will be lifting off in a couple of minutes.
How is that possible?
You can see it up on the screen. And Joel El Gaghi, the DDO, will be announcing the separation or drop-off of the upper composite
I'm French, and I can
umbilical
tell you there's
connectors any
definitely a
minute
robot
now.
vibe. It's not
Now,
natural
looking
at
up on
all.
the screen, and yesterday, last night.
That would be like me talking about rockets like this. Rockets are very fun to watch fly into space. When you launch a rocket into space, an incredible amount of energy is exhausted in a very short amount of time. In that short amount of time, the rocket accelerates to speeds that are incomprehensible to the average person. In that time, a lot of heat comes out of the bottom. It's very weird. It's very
Business
very weird.
developer in charge of
Not
innovation
monotone
topics
enough.
at Arianespace and our Road to Space expert. Tonight, of course, you will be taking us through each stage of this delicate mission.
Is this
which
one on a drone
unfortunately
ship
was delayed
land or
twice in a row,
RTLS?
but we're
It's
back
gonna
again.
it's gonna
We're now less than
RTLO.
2 minutes away from liftoff. So my first question to you is the launcher now autonomous?
It will be completely autonomous 40 seconds before liftoff when we stop the ventilation of the launch vehicle.
We like you,
and when
American.
the Soyuz
Okay.
launcher is tilted from ground energy supply to onboard energy supply.
Look at how happy
And
everybody
from
is
that
to
point,
be there.
we will retract the upper and lower masts. And what you will see 16 seconds before
Okay. I'll take it from here. So this is a Soyuz launch. This is Soyuz 2-1. What the guys are saying is that it's very easy to see the carrier umbilicals retract. There's one that's going to retract at T-minus 30 seconds, and then there's one going to retract at T-minus 15 seconds. Once the second one goes, you'll get down to T-minus 6, and that's when they'll trigger the engine ignition. The engines will turn on at T+0, and the vehicle will be released from the launch pad at T+6. It's just a little bit different than kind of what you'd see from a more Western-style launch vehicle. So, we're 50 seconds out here. Let's see what we got.
But just to remind you all that this is the 13th launch of the year for Arianespace.
Is this the first launch of this rocket? Don't
61st
remember
mission
seeing
for the
Soyuz
European
ever fly
Space
before in
Agency,
the past.
and
Yeah.
the 150th mission launched by Arianespace for
Largage
European
du Mac AZM.
institutions.
Okay, there it goes.
Stop commenting now.
Yes, please.
À tous de DDO, attention pour le début de la séquence d'allumage du lanceur.
It's Jezuku. What's up, dude? 20 seconds.
Top.
Stop.
Largage du MAVKM. Allumage triétage. À tous de DDO. Attention pour le décompte final. 10, 9,
Show the engines!
7, 6, 5, 4, 3, 2, 1. Top. Et décollage VS26, Galileo Foc M9.
There he goes. French Cosmos sucks. Bro, you didn't even show the
Les
best
paramètres
part!
normaux.
What are you doing? Oh my god.
Raphael, that was very impressive. That a
Yeah,
ball
real
of fire
impressive. Saw a
Bolting
picture of a
into the
cloud.
sky.
Stabilisation du lanceur.
I cannot get tired of it.
I bet.
Like really, it's always very impressive. And this is like, passing through the clouds.
What sort of speed is it going at
It
now?
is night. You cannot, you can hardly imagine that it's night right now because it's
Stop!
so bright.
It's so
Stop!
The
bright.
lights.
Stop it!
So right now, Soyuz
Stop
is doing
talking!
the main
Nominal.
thrust for the mission to
You
escape
stop this
really
now!
the gravitational
Alex!
pull
Alex!
of the Earth.
Explain!
And in a few seconds,
What is this?
we should
Qu'est-ce que
see
c'est ça?
the separation
Just-
of the four lateral boosters
No!
that are surrounding the main core. I mean, you can.
I mean,
imagine
it's
that in
amazing,
2
man. Like,
minutes,
the
Soyuz-
rocket, like, is flying, man. It's, like, amazing. It lights up the sky, bro. Come on!
Bonne
seconds.
stabilisation du lanceur. Tous les paramètres à bord sont normaux.
Like what
This
is
is
the
probably
DDO
now
saying?
faster than like a bullet, faster than a
Faster
bullet
than
right
a bullet.
now. Yeah.
You've got the earpiece. What is the DDO? What did you just say then?
It said that everything is nominal, the trajectory is nominal, so everything's looking good for Soyuz right now. So you can see the light coming from the four boosters.
So in 10 seconds, we will have the...
It's like watching Jim Nantz comment a football game. I just can't do it. Okay, so there's first stage separation. 4 boosters popping off the sides, forming the Korolev cross. Second stage is still burning well. Keep in mind that on a Soyuz rocket, the second stage or the center core is burning the entire time. They light it at ignition here. So right now, Soyuz is down to a single stick here. That forms the second stage, which is what we would call generally a core stage here in the States. And then you have the third stage on top of that with the payload fairing. Right before second stage flame out, they will fire the third stage engines. Yes, you heard that right. Soyuz fires its upper stage engine up here while the first stage is still going. The reason why they do that is it's a technique called hot staging, and the reason why that happens is because they want to make sure that the propellants during the separation event, they want to make sure that they stay down at the bottom of the fuel tank. Because now, if they shut the engines off, you're under no acceleration. There's no acceleration force because you're falling, technically. So during staging, you have to find a way to keep the propellants down at the bottom of the fuel tanks. The Russians came up with the idea, or Sergei Korolev is the guy that came up with it. He's the chief designer of Soyuz. He came up with the idea of firing the second stage, or the third stage engines for a split second while the first stage engine is still lit. That's why Soyuz has a hollow inner stage right here. They're going to hot stage this thing in a second here. And when they do that, they'll separate the fairing as well. Or at least they should. We have separation coif, which means fairing separation.
Which is a wonderful image of the launch vehicle. What can we see?
So this is the live telemetry right here. That's right.
Speed.
So
we're in the track. Everything is looking good.
And 17 kilometers.
Now they're going to pop the fairing before they hot stage, which is.
In 3 seconds, we will also be having the separation of the fairing. There we go.
Separation.
Attitude du lanceur, conforme à l'attendu.
That's just been confirmed, has it not?
It is confirmed.
Séparation des deux demi-coiffes.
So now it's confirmed. And it's a
Separation
very
du
good
coiffe.
news because the mission can continue. You can imagine that it's an important step. Otherwise, we could not release the satellites into space. So it means that we are above the atmosphere.
Now it's fast like a
and
few
the
bullets.
satellites don't need the protection of the fairing anymore. It was protecting them from the friction.
Okay, so this has a little bit of a different ascent profile here. They jettisoned the fairing before they hot staged it, but in the graphic, you'll see the engines turn on for a split second while the first stage engines are still firing. They're going to hot stage it. Once again, that's for what's called tank ullage, to make sure that all the propellants stay at the bottom of the fuel tank. And they didn't show it.
Separated from the rest of the launch vehicle. And it should come
that didn't animate exactly right.
There we go.
Interstage separation.
So waiting for the confirmation of the DDO. Because I remind that this is 3D simulations here.
Allumage bloqué, extinction bloca et séparation.
So it's confirmed.
That's brilliant.
Flame out on the second stage, third stage ignition confirmed from the director of mission operations there. Everything's looking good here. Now this should basically fly the rest of the way into space. And then once they get a good parking orbit here, the fourth stage on Soyuz, which is called a frégate, which is that it looks like it's wrapped in some gold foil around like underneath the satellite, but on top of the third stage. The frégate stage will provide precise insertion here. Now these satellites are relatively light, so this second stage is the third stage is gonna burn for a little while. That's the frégate upper stage. That's what the Russians use as a fourth stage on Soyuz. It's an attachable stage. You can either use it, you can have it there, or you don't necessarily need it. In this particular case, because these satellites are going to a MEO orbit, so medium Earth orbit, so about 12,000 miles that way. They're going to need the frégate to be able to put these satellites in a precise orbit here. Right now, so where the altitude on the vehicle is 170 kilometers, distance downrange 800 kilometers, and the velocity is 4.5. You're about halfway, a little over halfway of the ride into space here. Someone is behind me. Ah! Ah! Over here we have the ground track, showing that this is going into a inclined orbit here. So it's an orbit that's tilted relative to the equator. Yeah, Alex, so he called the director of operations called the hot stage correctly. These guys didn't.
Ocean. In this case, this is a ship that is equipped with an antenna that we position on the ocean a couple days before the launch.
So this is a mobile station on water, literally.
Yeah, and it raises some logistic issues because we need to position the ship in advance. The ship really
Acquisition de la télémesure par la station navale.
Okay, very good news. The ship needs... Yeah, I said that it's...
So they're using ground tracking stations that are on boats. Because if you're launching northeast, the European Space Agency uses ground tracking stations. You can see there's the 2 ground tracking stations. They're sitting in the Atlantic right now. Santa Maria and SNA. And then once it gets out over Europe, they'll be able to communicate with a ground tracking station that's on continental Europe here. Right now, the thing is flying northeast out of French Guiana. So it should be up over the UK and over Europe pretty soon.
Of the launcher, and it drives what we call the ground track. It is, in a way, the shadow of the launcher on the Earth's surface. And right now, the inclination of the targeted orbit
fellas, why aren't the Vernier engines firing in this animation?
Degrees with respect to the equator. And we have the obligations to continue.
So, fellas, see these little thrusters that are on the outsides here? 1, 2, 3, and then there's a 4th one over there? Those not firing in this animation would be like an animation of a car driving down the road and the front wheels not spinning. That's the steering. Those engines, those little thrusters right there are called Vernier Thrusters. That's how Soyuz steers. The engine on this thing is actually fixed. Those 4 nozzles don't move. They're fixed in position. And then it uses these tiny little thrusters on the sides to be able... Those thrusters actually wiggle back and forth. And those are called verniers, and they're used to steer the vehicle. Not having those firing in the animation, like I said, is like showing a race car driving down the road and the front wheel's not doing this. There's a global supply shortage of gimbal authority.
And when we target the sensitive
Here's an honest question. If they are launching equatorially, why not just launch a Soyuz from Baikonur or Vostochny if the low inclination isn't needed?
And the DDO just said that everything is nominal right now.
So can you just tell us at 9:23, 9 minutes 23 seconds, he will be announcing what?
Well, the separation of the third stage, which is another very important step here.
It's
stand by for
the
forgot upper stage ignition.
We are waiting. Yes, we are waiting for the confirmation, of course, from the DDO.
I think
is this Kerbal too?
The most wonderful image I've ever seen of this type of golden mushroom.
Yeah,
what is that?
This is the frégate upper stage.
Extinction du bloquis et séparation.
So it's confirmed. The third stage has been separated, and right now it is the frégate upper stage that is going to continue the mission. It is.
I'm calling it that from now on.
That is going to place.
Sorry, Russian viewers. I'm calling it the golden mushroom from now on, dude.
Orbit, separated orbit.
Golden balls.
And from there, the Galileo satellites will
place
themselves on their operational orbit.
So can you just tell what is it exactly in a couple of words?
The golden foil on this thing is insulative material. They don't necessarily need to keep the propellants cold, but they do need to keep the propellants at basically a pretty standard temperature. So all this wrap here is MylaWrap. It's just insulative material to make sure that the fuel doesn't freeze and or boil.
Which is quite long because it requires some energy to place the upper stage on this.
What is that? Is that a light bulb coming out the back?
So we're still waiting for confirmation.
Exactly, and then we will have a long ballistic phase of about 3 hours and 20 minutes.
Confirmation du premier allumage de l'étage.
Guys, come on!
That's confirmed.
Europe, guys, you're making this so difficult.
One of the most important steps for the missions, yes. So I was saying that we will have 13 minutes of ignition of
Why are you doing this?
Then we will turn the engines off, and the Soyuz, the frégate will follow the path. Engines off for a long ballistic phase. It will be like coasting in space for 3 hours and 20 minutes before it reignites. And this time it will change also the trajectory from an elliptic one to a circular one.
A circular, okay.
Yes, which is going to be the final orbit where the satellites are going to be separated into space.
It's moving at an incredible speed. What can you tell us about this?
Yeah, so right now it's
You can see the naval station coming into view on our...
Yeah, exactly.
That's a loss of signal, fellas.
So
we will go from...
Acquisition de la télémesure par la station de Santa Maria des Açores.
Okay.
So
what I was
is
about
happening?
to say.
Tell us, Raphael.
Yeah, it means that the next telemetry station...
This is a handover. They lost the track from the ship, but they'll have reacquisition through the next ground station at Santa Maria here.
Located west of the Portugal, it's in the Atlantic
I disagree,
Ocean.
Alex. I want Katie Haswell
and like
back.
I said, it is now taking back the signal from the launch.
I liked her and the other
dude's
dude's commentary. The American that was there.
It will last 3 hours and 50 minutes in total. So yes, this is an unusual, particularly long mission here.
So,
can you imagine that in 12 minutes we have traveled 3,400 kilometers?
It is quite
We have
incredible.
crossed the Atlantic Ocean in 12 minutes.
Altitude,
and
for
right
sure.
now
It's not losing
it's
velocity.
It's approaching Europe actually, and it will pass above
Les paramètres
England.
propulsifs de l'étage frégate sont nominaux.
So
everything in nominal.
So we're about to lose, or we've lost the naval station. The expert Raphael has confirmed the loss of a naval station.
Yeah.
So why are we losing the signal? For how
Velocity
long?
kicking.
So this is completely normal. We lose the signal when, from the telemetry station point of view, the launcher disappears behind the horizon.
It's weird because we're still getting updates from altitude and distance, but not from. We don't have a velocity component. This is usually live telemetry, so with this, and this, if something goes weird like that, it's usually not a good thing. But once again, the director of operations is still calling out everything good, and the telemetry here is showing that you're perfectly in the track. So let's keep watching. We'll see.
Loses the signal before the next one recovers
Everest,
it.
that's a 1/10 of a meter a second. Thank you.
Well,
that's how the NASA
thank
guys
you,
say
Raphael. In a couple of minutes, the two satellites will be orbited into space to join the Galileo constellation, 23,000 kilometers above our heads, which is quite incredible to think of that.
Les paramètres à bord sont normaux.
They have, however,
yeah, of course
already
Whitney does a
traveled
better
a
job.
long
Whitney
way to
should be
get
doing
here.
this, Alex.
And we have some footage
You and
we'd
Whitney
like to
should
share,
be
which
doing
dates
this. How
from the
about
start
that?
of the Galileo satellites and launcher campaign, and it will be coming up on our screen shortly. And Raphael, as usual, I'd like you to
No
comment
offense to
on that.
Raphael or the woman here, but you and Whitney
Of
can do a
course,
better job,
if
Alex.
the image come,
You do a way better job than these guys.
because obviously it's a long work.
There, here we are.
before
Oh,
the
here is a
flight.
boat.
So here we see that the launcher elements arrive by boat at the Guyana Space Center. So they are stored in large containers, and the Soyuz assembly is done in the
You know what you're
integration
talking about,
building
Alex. I would have
coordinate.
confidence that
So
you and Whitney could do a hell of a
the
job.
integration is achieved horizontally, exactly what it's done in Russia. And the lateral booster here are first positions around the central core, on top of which the third stage will be attached. And you can see that the operators
They look so
very
small,
small,
they look
right?
very
Yeah,
small.
on the image. So it's quite impressive images that we see
It's
here.
vast.
Ooh,
And
an
in
illusion.
parallel,
Nice.
the satellites arrived by plane. The two Galileo satellites arrived by plane and were transferred to the preparation building. There, many operations are done.
Why didn't you
in
show
clean
this
rooms.
before the launch?
Satellites are removed from their container. They are integrated on their adapter.
They're
they are
dust
fueled.
inspected.
Yes, exactly.
You should.
And like you see, and like you said, these are very, very careful operations.
The golden
And
mushroom.
you will see that
That's the name for
after
Forgot
this,
Upper
the
Stages now.
satellites
From now
will
on, dudes.
be transferred
Golden
to another
mushroom.
building where they are carefully
This is cool.
mounted. So they are protected here for the transfer, and they are
That's
carefully
cool.
mounted on the
Oh,
frigate
dude, you
upper
should have
stage
showed
first.
this. This is dope. There's the
Together,
golden mushroom.
they
There it
are,
is.
You can see here, with this golden jewel,
It's
like
just-
that
it's-
you
it
mentioned
does.
before.
It's a technological
they are
jewel.
encapsulated inside the fairing that will protect them from the
Cool.
friction of the atmosphere during the assembly
Friction
phase.
from the atmosphere.
And this assembly structure is what we
Friction.
call the upper composite. And there you see that the Soyuz is transferred to the launch pad horizontally.
yeah,
It
yeah,
is,
man. That's a great
tilted in
name. What
vertical
were you saying a
position.
second ago
This
about
operation
getting
is
your mind
very
out of the
also
gutter?
impressive.
What was that?
And,
Did I hear that right?
we will place the upper composite on top of it. And now it's ready for flight. a beautiful flight that we saw.
So since this operation, what has
Still no indicator from the velocity component here.
Can you tell us about this Soyuz launcher?
Yeah, we had a lot of operations that happened.
Fonctionnement nominal de l'étage frégate.
That happened for.
He's calling that the
9
numbers are
hours
good,
before
but
the flight.
it seems like they might have a
Lots of
bad
operation.
sensor here.
And we saw this magnificent flight happening.
Yes, in 1 minute, the DDO will announce the extinction of the first frigate ignition and the acquisition of Osogel. This will be the beginning, obviously, of a very long phase during which will be cut off comments, but you can continue to follow the
We
end
need
of this
Golden
mission
Mushroom with a
and the
ball
celebration
beam.
of its 2 satellites on Twitter. As I say, we're waiting at 1822, around that time, for the acquisition of Osogel, another station.
Why is this
Osogel,
cast
which
the way
is
that it is?
located
Why?
20 kilometers south of Toulouse. So it really means that the launcher is going to
Is that a
pass
light bulb?
in not too long.
Not the
above our
golden
head.
mushroom.
Yes.
That's brilliant to think that. So the flights follow a path of different stations along its trajectory. How many will there
Jen,
be until
these
the
are
end
tracking
of the
fine.
flight?
Sont normaux.
That's
so
no
after
good.
Oswagel, there is going to be another one, new Norsca, that will follow the trajectory
But
until
see the circle in the
mission.
X? If the X stays
So we're
inside
just
of that
seeing up on
circle,
the
that means
screen
we're
now.
good.
We're about to
So I'm
lose
not sure what's
Santa
going on
Maria,
here.
And we're about to acquire Osogel. Can you see there, Raphael?
Acquisition de la télémesure par la
Si.
Yeah, we
station
can very
d'Osogel,
clear. We can
Toulouse.
see the trajectory,
It's
the
going
path
to.
very clearly.
You can,
If you're in Europe, guys, you should be able to see this. You should be able to see the frigate upper stage firing. The golden mushroom. It'll look like a candle moving across the sky. You trust me, you won't be able to miss this. If it's a clear night and you're in France, I'm serious, look up. You'll see this thing. No problem. The engine's still firing. You'll be able to see it. Which way do I look? Up. It's like right above you. I mean, it's not over France just yet. It looks like it's kind of near the Iberian Peninsula. It's cloudy. Sorry.
Our 2 satellites,
Oh,
the
guys
2
on the
Galileo
phone.
satellites, are the 23rd and 24th satellites to be put into orbit by Arianespace. For the
Okay, so
European
that looks
Commission.
like Portugal right
The
there.
previous flight started in 2011.
So there's
which-
Madrid. We're
there are
looking
both
at it upside
particularities.
down, which means...
Raphael, can you tell us about the history of Galileo, which is the largest constellation ever built by the European Space Agency for the European Commission?
Yes. Like you see, the first Soyuz was lifted off from French Guiana in 2011. This was actually the first. This was for Galileo.
I don't know, Kiosk, I'll have to look at it.
First
I
Soyuz
think it's
flight
because
was
the
for
orbit
Galileo, and we're
changes. The
celebrating the
eccentricity of the
20th,
orbit changes, so the amplitude
years
changes on the ground
anniversary
track.
of, this launch vehicle. And since then,
Vehicle.
we performed 7 Soyuz flights orbiting 14 satellites and 3
Nice.
Ariane 5
Nice.
flights orbiting 12 satellites, because with Ariane 5 you can actually accommodate
Eta
4
oro show.
satellites at a time. With Soyuz, we launched 2 satellites at a time.
So how long
Yeah,
has
Joe
Arianespace
show.
been serving the institutions?
Since the very beginning, since the creation of Arianespace in 1980, it has orbited a total of 180 satellites for European institutions, for the European Commission,
that
of
sucks,
course,
Sebby.
for the European
Has there
Space
been any launches that
Agency,
go over Western
and
Canada? I
for
feel like I haven't
11,
seen one that
I
comes
think,
near here.
Different countries in Europe.
Tars, you'll
For many
most likely see
applications,
satellites and
Galileo,
stuff,
of
but
course,
yeah, where the
the
launch sites are, it's
Copernicus
kind of
program,
tough. You could
which
see
is the first
satellites though.
observation program
The
of
satellites,
Europe,
like you
for
should be able to see
meteorological
Starlinks if you're out in the
satellites,
middle of nowhere.
for environment
You could see them clear as
monitoring,
day
defense program,
during
and of
dusk. You'll
course,
see them; they're all over the
scientific
place.
And exploration
For you,
missions.
the satellites
So
will be
what are
going
the most emblematic missions,
northwest to
Raphael,
southeast.
that Arianespace has launched for Europe, for example?
That's very difficult to choose, of course.
Well, what are your most emblematic
Well,
ones?
I mean, I remember.
Squishin, they're gonna launch
I
from
was not working
Tromsø,
for
if I'm
Arianespace at
remembering
that time,
right.
But
Okay.
I really remember the launch of Rosetta. In
Is there ever any launches that go?
2004.
Okay, I already read that.
It's a space probe that reached the comet Chury 10 years later, and deposit like a small Philae robot. It was very,
I'm not surprised you remember
very
that one.
yeah, it's very emblematic. The BP Colombo
Nice.
space probe that was launched in 2018 to explore the Mercury planet, which
Nice,
is the
Lucio.
closest to the Sun. And
Me no
I
spiel.
also can
Oh,
think
I like
of,
this shot from the
flight,
mobile service
in
tower.
2018.
Very nice.
The
Very
Adele
nice.
ALICE, which is an ESA program
Very nice.
dedicated to the study of wind profiles in the atmosphere. This is an example of missions.
They're also building an
dedicated to the
orbital site in
environment
Kiruna right now.
management.
Sweden,
What's
right,
next
Jock?
on the agenda then?
If I'm remembering right.
Well, I'm sure that you know that on December 20,
Yeah, that's the Galileo fuck M6.
we will launch the
time.
James Webb Space
That is-
Telescope.
What?
Which is
Really
going
This
to
is
be
fuck
absolutely
27 and
amazing
28.
with Ariane
Incredible.
5. It's the biggest
That's what it's
telescope
called.
ever deployed into space.
What?
It will replace.
I'm not
the,
swearing, that's
current
the name
Hubble
of it.
telescope. It will be placed
It's called
Yes,
Galileo.
Where is it gonna be
at
placed?
1.5
Called Galileo fuck
million
27.
kilometers.
Go look at the name. I'm not making that up.
With
5
unprecedented.
million kilometers from
Yes,
the Earth.
exactly. To study with
I'll be noting
unprecedented
down that
detail
figure.
the deep universe, because you.
That's the
probably
name of the
know
satellite, guys. What do you want me
the
to
more
do?
distant you see, you look.
No,
the
FOC.
closest
Fuck.
You are from the origin.
Fuck
of the
27.
universe, which is the Big Bang. So
That's
it
the
will
name of the
really
satellite.
witness The birth of the most distant galaxies of our
Fuck.
universe.
Fuck me?
And
No,
I'll tell you
I'm not a
also another
satellite.
one
Fuck
that will
you.
take off, shortly after, it is the JUICE space probe.
I am not a.
Which will
I'm not a
look
satellite.
at
Last
the
time I
moon of
checked.
Jupiter,
Okay.
which has really fascinating worlds where scientists expect to find some
I'm
forms
sorry.
of life. It is going to be
Oh
very,
my
very
God.
exciting.
Well, Raphael,
Soon,
we're just
Pythos,
about to
soon.
have soon the first phase of the frigate
That's-
ignition extinction.
Frigate.
The DDO will announce that to us soon.
Oh yes.
Look, coming up on
Golden
our
mushroom.
screens. So the two satellites on board the Soyuz launcher tonight are Galileo M9, Sat 27, 28 we call them, and they're the 27th and 28th in the constellation. So, Raphael, where are they now?
So we are waiting for the confirmation of the cutoff of
But
the
where are
frigate
they now?
engines.
If you look at the map up on the screen, they're floating,
Can you see?
coasting.
Can you recognize?
Can I recognize?
It looks like they're over Lithuania.
Is it England?
So right now, just to tell you that right now it's 600 kilometers of altitude, which is quite high.
I don't know
So
where
we
it
are-
is,
we-
but you're going to tell me.
All right, that's enough cast for the day.
So we're still, as I
That's
say,
enough
waiting
cast
again
for
for
the
the announcement of the DDO, and confirmation from the DDO
Is it
of the
England?
frigate extinction.
Yes, exactly.
England's over here.
Confirmation de l'extinction du frégate.
Okay, confirmation of
Another
the
very
frigate
important step,
flame out.
because we have the confirmation of the extension
Bro.
of the frigate
you mute
engines.
them,
So right now, it's a rather long journey that is
It's out almost over
waiting
Moscow
for
right
the
now.
frigate. Is going to stay there.
It's smiling.
for 3 hours and 20 minutes.
Okay,
We will have a
so this is on a medium transfer orbit, or MTO. It's a Hohmann-style transfer orbit with the apogee out at about 12,000 miles, or what's that in kilometers? 17,000 kilometers, or 18,000 kilometers up. And the low point of the orbit is at about 180. What this thing is going to do, it's basically a very egg-shaped orbit. And the end of, like at the top of the egg, right, so to speak, that's where it's going to deploy the satellites, and the satellites will position themselves with their own thrusters. And then the frigate will turn around after it dumps the satellites, and it'll fire its engines, and it'll come back down and burn up, because the lower point of that egg-shaped orbit is right near Earth's atmosphere. It's over here somewhere. So that's part of the reason why the orbit looks so weird like this, because if you look at a ground track, and a ground track is an orbit superimposed on a 2D map, so the orbits end up looking like wavelengths, with a polar orbit being very high frequency, high amplitude, right? And an equatorial orbit would be a straight line. So the reason why this orbit kind of goes like on a nice arc, and then why it goes pretty much straight, is because of the eccentricity of the orbit. And then the orbit basically, from now on, after this, it'll look like that. So that's the Caspian. That's the Aral Desert right there. So Baikonur is right over here. We're looking south. This is south. So that's Ossetia over there. So it's between the Caspian Sea and the Black Sea. So that's like Georgia and stuff.
Discovery, go at throttle up.
Insert clever resub message here. Hi, Pie Guy. It's England. Yes, this is England right here. Those are the British Isles, you can see. And then this is, in fact, Japan. Japan's sending PlayStations. The X went off the circle. Uh-oh. That's just a loss of signal, dudes. That's all. Actually, let me take a look.
Space mission of the Soyuz mission.
Let me watch.
But this is going to be the beginning of the life of the satellites. Let's hope for many years to come in order to deliver all the applications that we've heard earlier to the citizens.
Well, we are about to lose the visibility of Asogwell, and I would like to just thank you, Raphael Chevrier, for being with us tonight. At this late hour,
that's
morning,
off nominal insertion right there, guys.
There we go. The DDO has just confirmed.
That's off nominal. That's off nominal orbital insertion right there. I don't know what the hell this thing is saying. The velocity meter broke. It is out of the track. Oh, was that altitude going down? The altitude should not be going down right now. These numbers are messed up. This isn't right. These numbers are this isn't right.
The applications that we've heard earlier.
Oh crap, hands on the face, not good. Anytime you see flight controllers in mission control doing this, or this, or this, or this, something's bad. Your melon's in the way. The direct, okay, look. Watch. That. See that? That's not a good thing. Something weird is happening. That's a good indicator. Uh-oh. I'll just move over here for now.
Heard going to be.
Let me watch these numbers again. 840. These numbers don't make sense. I mean, obviously the velocity component doesn't make sense, but it shouldn't be going down right there. So, guys, I might chalk this one up to a telemetry error, but honestly, a telemetry error is not a good thing. Are you sure it's not just signal drop? Well, it could be. It could be signal drop. It's possible. But a signal drop doesn't take 30 seconds. See what I'm talking about? I'm skipping every 10 seconds here. A signal drop doesn't take 30 seconds. The telemetry numbers would just go blank. Why not listen to the broadcast? Oh, okay. No, here, let me back it up. I'll listen to what they were saying. It could just be a loss of signal. It's possible.
And the trajectory, and it's going to be at 23,000 kilometers from the Earth. And shortly after this, the satellites are going to be separated radially.
Guys on the phone.
And they will reach their own operational orbits using their own propulsion means. And from there, it's going to be the end of Arianespace mission, of the Soyuz mission. But this is going to be the beginning of the life of the satellites. Let's hope for many years to come in order to deliver all the applications that we've heard earlier to the citizens.
Well, we are about to lose the visibility of Assoguel, and I would like to just thank you, Raphael Chevrier, for being with us tonight at this late hour, now early morning here in Paris, and helping us to decipher. There we go, the DDO has just confirmed the loss of visibility of Assoguel. As I say, not always easy the different stages of today's VS-26 mission to explain, but you've explained.
Yeah, Ian, I don't think this is anything. This seems like it's just it seems like their telemetry is screwed up, but the rocket is doing what it's supposed to be doing, which is strange. I mean, I wouldn't trust a bad sensor like that, but I mean, if the telemetry is screwed up, like, how the hell do you know it's in the right orbit? I don't know, Jacob. It's very strange. That was weird. Let me back it up again. Hold on. I need to, let me just play that sequence of events again. I want to watch what the controller's saying.
So, what's the
because, like I said, the velocity component was really messed up the entire time. That's been wrong for like a couple of minutes now.
The second booster frigate is going to circularize the trajectory, and it's going to be at 23,000 kilometers.
But see, no, wait. This is graphics. This is the telemetry. This is live telemetry. These numbers here. This is not a graphic. That's the graphic. This is always right. And every time, I'll be honest with you guys, every time that X has gone out of the circle, it's been indicative of two things. A signal loss, as expected, or the thing didn't work. So, I'm coming down more in favor of signal loss here, but let me listen to it again. I want to listen to what this guy has to say.
Operated radially, and they will reach their own operational orbit using their own propulsion means. And from there, it's going to be the end of Arianespace mission, of the Soyuz mission. But this is going to be the beginning of the life of the satellites. Let's hope for many years to come in order to deliver all the applications that we've heard earlier to the citizens.
Well, we are about to lose the visibility of Assoguel, and I would like to just thank you, Raphael Chevrier, for being with us tonight at this late hour, now early morning here in Paris, and helping us to decipher. There we go, the DDO has just confirmed the loss of visibility of Assoguel. As I say, not always easy the different stages of today's VS-26 mission to explain, but you've explained them to us wonderfully, and I must thank all the teams here who have helped us prepare this program in Paris. Say see you soon, everybody, on Road to Space for the next fabulous adventure.
6 minutes.
And don't forget to follow us on Twitter for the rest of the mission. And I must say goodbye to this wonderful golden mushroom.
Next AOS is in 46 minutes, okay.
Coasting in the
into
airs
space
tonight.
Hold on. Alex, what do you think? You think it just was a loss of signal? I think it was probably just a loss of signal, dudes. But we did see the guy do this. I'm telling you, anytime you're watching flight controllers, if you see the flight controllers do this, if they... any hands on face means something weird happened, or something that you didn't anticipate happened. Like, this is usually bad, this is usually bad, this is really bad. It's like the further you get up, right, the worse the problem is. We're arguing with it over on Discord. It's the most probable cause. A frigate failure could be the cause, but it's the frigate. Alex, something went wrong with the telemetry, though. And I'm wondering what that is. my opinion, he got a call about his expired warranty. If they do a knot like this, that means catastrophic failure. If it was a loss of signal, I mentioned well, in the past, guys, when we have loss of signal, the telemetry freezes. It doesn't do anything. It just stops updating. It doesn't go up and then it go down. Like, anytime Arianespace has had a loss of signal in the past, the numbers are like, okay, 800 kilometers, 900 kilometers, 950, stop, loss of signal. And then when they regain loss of signal, it'll be like 1050 later. Or when they regain acquisition of signal. I've never seen the telemetry break off like that and then just go in different directions. But then again, the velocity was totally screwed too. But here, let's go back and look. Sorry, headphone users. I clicked literally right at the loudest point. When does the velocity start acting funky? Let's take a look.
The launch vehicle.
I just want to look to see when this thing takes a dump.
That was the launcher. And we have the orbit that really drives the trajectory of the launcher.
Okay.
And it drives what we call the ground track. It is, in a way, the shadow of the launcher on the Earth's surface. And right now, the inclination of the targeted orbit for Galileo is 57 degrees with respect to the equator.
That's what it looks like. See that?
We have the obligations to continuously monitor the position of the launcher up to a certain altitude. And
Les paramètres à bord sont normaux.
sometimes
Alex, what did he just say? Repeat? Okay. He said that it was nominal. Hey, Whitney, how are you?
to continuously monitor the position of the launcher up to a certain altitude. And
Les paramètres à bord sont normaux.
Okay.
sometimes, like today,
Good, and
it happens
you?
that we
I'm
cannot follow
wondering.
the launcher.
No, I'm good. I'm wondering what happened with that Soyuz during the loss of signal. I've never seen the telemetry wonk out like that. That's very strange. I mean, I hope everything is good, obviously, right? I'm pretty sure it's just a loss of signal, but there seems to be something wrong with the downlink here. Parameters à bord sont normaux. Parameters on board are normal. Got it. Okay. It seemed like the handover between Galileo, forgive me if I butcher the French language. I'm very, very sorry in advance. All right. From Galileo to SNA to Navy Station, something weird happened with the telemetry. Galileo handover glitch? Yeah, maybe. He said Peugeot Renault. Yeah, okay. All right. Yeah, okay. We butcher English too, don't worry. It's tough, man. It's tough tongues to switch in between. So that's when the telemetry took a dump, right here. There was like a momentary loss of signal. See, right there? That usually is a handover between ground stations, guys. That's normal. That happens all the time. But usually when you reacquire, you get the right velocity. See, it goes from 5.67 kilometers a second to 0. That's not good. So something went weird with the down. That could just be the downlink. The rocket could still be working fine. Maybe the station handover is in the U.S. and it reads in imperial numbers. Cam, do you think the Russians would let Soyuz downlink with an American ground station, man? Not a chance, bro. Not a chance. And everyone butchers Russian. Do. Oh, I mean da. Sorry. Yeah. They're going back live. All right. Let's see. Let me back up. Oh, we had live telemetry there for a second. Yeah, see, there's the loss of signal right there. That's normal. See it's going down like that? That's normal. Right now she's showing perfect in the track. 3,800. Let me see the distance. 14 kilometers down, 7.17 kilometers a second. Yeah, those numbers look good. We're in the clear. We're in the clear. That's perfect. Yeah, it's perfect. Perfect. Everything is fine. Yeah. I knew Soyuz wouldn't break, guys. Look, it's a Russian rocket. It's not going to not work. It's just a loss of signal glitch. Yep. Just some weird telemetry handover. Everything's good. If Soyuz doesn't blow up, it's going to be on the track. Yep. Yeah, Whitney, I think we're in the clear. Let me see that telemetry one more time. Yep, that's fine. So, okay, why is it fine? You want an explanation? You got it. Here. So, altitude, 3,700, indicating an altitude increase. So this is indicative of an eccentric orbit. If you were going out of an eccentric orbit past perigee, your velocity would decrease. You would increase potential energy. Orbital velocity at perigee with this type of orbit is above 7,600 meters a second. Because orbital velocity at 180 kilometer circular orbit is... Orbital velocity at about 180 is about 7,600 meters a second. Standard. So because this thing is in an eccentric orbit, at perigee it would be going actually faster than that. It would be going, I don't know, for this type of insertion, probably 8,000 meters a second, or about 8 kilometers a second. Now, if you look at the telemetry over here, 7.18 kilometers a second, indicating a deceleration. Deceleration with an increase in altitude means an eccentric orbit, meaning that the orbit isn't circular. It's elliptical, which that means you're right in the track. Everything's perfect. Yeah, this is fine. What about the time where it didn't work and the crew had to abort? MS-10? S-Master? MS-10 was just some guy not torquing a bolt all the way down. I'm pretty sure they fired that guy. Soyuz is beast, man. I mean, ask what other rocket that moves crew do you know has a catastrophic failure and the crew launches a month later? I'll wait. Replay the liftoff, the fairing wiggle. That's totally normal, Swishio. Fairings oscillate, man. They're like paper thin. That's totally fine. Yeah. So Whitney, we're in the clear here. Also, Whitney, why aren't you doing the Road to Space casts? Honest question. Why aren't you doing this? The satellite flew over Lithuania and they're like, oh yeah, it's over England. You could do, you're better than this. No offense to these guys. Like, I'm not trying to be a jerk, but who do we have to talk to get you to commentate these casts? We were asking the same question. I'm like, what the hell? There, what is that about? They are big guys. Do you want me to ask? I'll ask for you. Why can't we get Whitney to do it? She's better. She's better than this. Air in space is pretty big. So? Would it hurt to ask? I'll go ask. I'll go knock on their door. I'll fly over there and be like, yo, you suck. Get Whitney to do it. They'll probably be like, get out of here, you filthy American. That's probably what'll happen. At least that's what'll happen in my mind. That would be actually kind of fun. Can we do that? French Cosmos. Who do we have to talk to? We'll talk to somebody. We'll figure it out. You know. But yeah, everything seems good with the Galileo launch, guys. I think we're all set. Scared me for a second, but French English with you and Whitney dual cast? Oh, jeez. Adendal, the French don't want me there. They'd be like, who the heck is this Yankee Doodle guy? Hit you with baguette. Ah! Do not hit me! Stop it! Stop it immediately! If they had me on there, I would commentate the entire cast in the accent of John Gilrad. I am a space commentator just like you, except I come from USA. Just mention elderberries and hamsters. Ah, yes. The King of the Britons method. Yeah, very good, very good. No, the French accent is not necessary. Come face your destroyer! Bama beat Georgia. Toll Road, feller. You're under arrest for the murder of Pierre Fouquet. We fought in your general direction. Yep, see? Check this out. Perfect. Right there. See? Egg-shaped orbit. It's going to go back down and come around over here. That's right on the money. We're perfect. Magnifique. Next, but I'm American. You all sound the same to me. How am I supposed to know the difference? I don't know. I'm American. What do you want from me? Remember, I'm supposed to be stupid. Supposed to be. Yeah, business, we're happy. We got it. We had a good insertion from the Golden Mushroom here. The satellites are on their way out to their medium Earth orbit insertion. Galileo 27 and 28. Falk M9 are on a nominal trajectory. EJ drives a Citroen now. Alpine. If we're gonna go with French automobiles. Alpine. Does that count? Alpine is Renault. That's fine. Oh, I'm sorry. Renault. You're welcome. Du good? Alpine? Marry me. That's a yes for the Alpine. Definitely counts. Sorry, what can I say? I have very exquisite taste. This is a family stream. You can't say things like golden mushroom insertion. They said it on the cast, bro. I am absolved. Boom. So business memo. Okay, so the golden mushroom is a forgot upper stage. The reason why it looks like a golden mushroom is because it's wrapped in insulative material. Why is it wrapped in insulative material? What is that like? Okay, fine. What are they trying to keep cool in there? It's not that they're trying to keep everything cool. They're trying to keep everything at the right temperature. Okay? The forgot upper stage, the reason why it looks so lumpy is all it is literally just a bunch of fuel tanks bolted together. The fuel tanks are spherical in design though. And because it's a hypergolic system, utilizing unsymmetrical dimethylhydrazine and nitrogen tetroxide, it's a pressurized system that needs a helium tank. So you have a helium tank that goes into the UDMH and NTO tanks, and it basically squeezes a fuel bladder inside of those tanks, and then the propellants get squeezed out basically a water balloon inside of the fuel tank to the engine. And when the reason why they're using UDMH and NTO is because when they combine, they explode. So when they chemically combine, they combust. And that's what makes the light bulb that comes out the back of this thing. That's what makes the rocket engine work. The reason why they use this on orbit is twofold. Okay? So on orbit, the NTO and the UDMH stay liquids. You don't have to worry about them boiling off. You don't have to worry about them decomposing. It's a chemical substance, so it just kind of sits there. But you do need to worry about temperature. You don't want them getting too hot. You don't want the NTO boiling. It's corrosive. It's not ideally good. You need to keep it inside of its tank with a liner so it doesn't corrode anything. And also, you need the propellants to stay at room temperature. They're already pretty good at doing that, but they need some extra insulation. But yeah, you can see the different fuel tanks there. 1, 2, 3, 4, 5, 6. There's 6 spherical fuel tanks here. And then the reason why it bows out and why it looks like mushrooms is because these are the helium tanks for each one. There's a helium tank there. There's 2 more here, and then there's 1 more over the last one over there. And then on top of that, the Fregat upper stage has reaction control systems that utilize basically a smaller UDMH NTO thruster for precise insertion. This is what the Russians use to get satellites into a very specific orbit. It's not the same without light bulb. How do you know all this? What's your background? Papa, I'm self-taught. Self-taught. Yep. What's the white hatch, you ask? I know that question's coming. It's the fueling access door. You gotta fuel it somehow. Can't wrap all the tanks up and then have no filler cap. It's behind that. You're welcome. I pay attention way too much. I read way too much about this. That's why I'm good at it. So NTO and UDMH are nice and stable independently in a temperature, but requires a steady temperature. Sounds also like H2 is a good material for diaphragm gas, but would be temperature sensitive. There are hydrogen propellants that go up into space business, but the problem with hydrogen is you have to store it as a liquid. Storing it as a liquid is annoying because you're storing it near 0 Kelvin, and if it's near 0 Kelvin, it boils because you have to store it at pressure. or else it ain't gonna work correctly. You'll get hydrogen gas. You have to keep it as a liquid, and that's really, really freaking difficult. What's the reason to not use rocket fuel and oxygen like other upper stages? Lazarus, same exact thing. If you're using kerosene, kerosene is great. That's great. That kerosene, it's just diesel fuel. It stays as a fuel up there. Diesel fuel doesn't give a frick if it gets warm or cold. But you got to remember, diesel fuel in space, liquid fuel is only half the battle, guys. That means that's only half of it. There's no oxygen up there. You can't have an air intake. There's no oxygen. So you got to bring the oxidizer with you. The problem is, oxygen, just like the hydrogen, is a pain in the butt to store as a gas. You could do that, but you can, in order for a rocket to have enough power to get up into space, or what's called C3, it's called characteristic energy. Basically, you need to have a certain amount of joules to be able to get up into space, right? If you don't have it, so you have to bring a certain amount of oxidizer, and how do you bring more? You store it as a liquid. Storing it as a liquid allows you to get more oxidizer in, enough to get into space. But the problem with oxidizer, with liquid oxygen, just like liquid hydrogen or liquid methane, is that it's cryogenic. It's cold. It's really freaking cold. In order for oxygen to exist as a liquid, it has to be freezing freaking cold. Like, I forget what it is in centigrade. It's cold. Maybe not Russia cold, but pretty damn cold. So it boils. You have to store it at extremely low temperature at extremely high pressure, and it boils like if you took water and put it to 100 C on the stove, it'll boil. It'll boil off. It'll turn to steam. Liquid oxygen does that. It turns to gaseous oxygen. So you could go up there, you could put your propellants up there, and it'd be fine, right? And the second it comes around and goes into the sun, they'll boil off, overpress the tanks, and the tanks pop. Yeah. Getting the fuel to be stored, boiling fuel to be stored for long periods of time requires a lot of extra energy. That's part of the reason why we haven't figured out refueling yet, because that's hard to move these boiling propellants around. We can do it down here, no problem. But up there, it's kind of a pain in the butt, which is why most spacecraft use hypergulls like the Fregat upper stage. It's very similar. A very similar reason. Like Dragon, for instance. SpaceX's Dragon capsule uses a different version of hypergull propellants. The Russians use unsymmetrical dimethylhydrazine and nitrogen tetroxide. Dragon and most American spacecraft use monomethylhydrazine and dinitrogen tetroxide. So MMH and N2O4. It's a slightly different thing. Does the exact same. It's like saying that, you know, this guy uses 98 octane and this guy uses 87 octane. Same thing. But at the end of the day, they're both hypergull propellants. But like I said, the point that I'm trying to get at is it doesn't matter if it's the Chinese, the Russians, the Americans, the Europeans. Everyone uses those hypergulls up in space because they're great spacecraft propellant. They're great spacecraft propellant systems because the liquid doesn't decompose. It doesn't boil off. The liquid fuel on the oxidizer, it just sits there. You do need to give it some thermal insulation to an extent, but it'll be fine. All right, drummer, see you, buddy. Couldn't you just hold the cryofuse in a supercritical state? That requires a lot of energy to do in space, Joe. The reason is because when you're on orbit, so take the ISS for instance, when you're in the dark, i.e. not in direct line of sight with the sun, the temperature goes to like minus 200 Fahrenheit. When you're in the sun, it goes to plus 200 Fahrenheit. The ISS goes through these thermal transients all the time. That's hard to manage with boiling propellants, with the cryogenic propellants. It's tough to manage. It's a really difficult thing to get right. You need a lot of energy to be able to combat it, because 1 second you're going to be, so for every 45 minutes you're going to heat it and then cool it, and then heat it and then cool it, and then heat it and then cool it, and then heat it and then cool it. That's hard to get right. It's difficult. That's why we haven't done it. So what will Starship do in similar situations? Lazarus, the idea with Starship is that you have fuel tanks inside of fuel tanks, the header tanks. The header tanks are vacuum insulated, so they're literally not in the sun. They're in the dark. That's inside of the shell of Starship. That's the idea. Fuel tanks inside of fuel tanks. If there's a Starship that's going to be up there for a long period of time, it's going to need some type of thermal insulative material. But with something like Starship, you already have a thermal insulative material. They'll do exactly what they did during the shuttle program. You know what they did? Turn the shuttle's heat shield into the sun. Simple as that. That worked just fine during the shuttle program. I can't see why a Starship wouldn't be able to do both of those things. And Soyuz spacecraft uses hydrogen peroxide, right? The Soyuz spacecraft, yeah. The Soyuz rocket uses diesel fuel. Diesel fuel and liquid oxygen. Go blue. That's right. Yeah, spacecraft. Refueling is not something that there's no grand conspiracy as to why we haven't done like on-orbit refueling. It's difficult. That's the problem. Just like going back to the moon is difficult. That's why we haven't done it in a little while. That's going to change soon. Either, you know, the meme lord is going to get there or NASA. Or China. I'm indifferent. I really don't care. As long as someone does it, I don't care. I really don't. But hey, yeah. Anyway, the Galileo 27-28 mission, perfect. Very good. The Soyuz did exactly what we wanted to do, and these satellites are going to be up in space soon to their final destination. And if you guys, if you're in Europe and you need to use your phone map navigation, you'll most likely be utilizing these satellites in the future. These are global positioning satellites. Indeed, Impy. Getting out of bed in the morning is difficult sometimes, but we don't draw the line there, so why draw the line with space exploration? Squishy, you're preaching to the choir here, brother. You are preaching to the choir, my dude. Almost up there. They're almost where they need to be. It's close. No, Pop, that was a different mission. That was the Russian Express satellite. That hasn't launched yet. This is a different thing. Bruh. One day warp drive. I hope so, man. I hope so. Up next is James Webb. Yep. Dude, I don't usually have butterflies anymore from a launch. With that being said, James Webb is gonna... James Webb is definitely gonna activate my almonds, if you catch my drift. I'll feel a lot better once they have good orbital insertion on that thing. Knock on wood, indeed, Phoebe. Indeed. Oh my goodness. Is it true that it's worth $10 billion? Yep. NASA's invested $9.7 billion, Pop, over 15 years. James Webb got on the books, dude, when I was in middle school. I haven't done any schooling in 15 years. Man, when you say it like that, Jesus. Okay. Do you know when James Webb will be fully operational? About a month after they launch it? What is James Webb? James Webb is a non-visible light spectrum observation satellite. It's basically like Hubble on steroids. Yeah. Yeah, it's cool, man. Yeah, that's right, Dark. The ESA contributed $700 million for the launch and a couple of sensor packages on James Webb, and the Canadians $200 million for operations, if I'm remembering correctly. Yeah, Evil Bit, we don't need to talk about that. NASA should be making multiple James Webbs and send it and sell them to other agencies. That way they could bring the cost down. Yeah, TLS, the economy of scale doesn't only apply to rockets, it applies to satellites as well. So yes, I agree with you. I mean, TLS, if I had my way, SLS would be slated for a mission to deliver like 5 or 6 Curiosity Perseverance rovers to Mars with like 6 or 7 Ingenuity helicopters attached to them. I'm talking about carpet bombing Mars with Mars rovers. Just stack them one on top of the other. Put it on an SLS and send it. It's 5 of them at a time. And have their trajectory slightly deviate after a Hohmann transfer insertion on transmartian injection. So one lands at the North Pole. Another one lands at the South Pole. Another one lands in the Mariner Valley. Another one lands at the Jezero crater. That's already been done. You see what I'm talking about? We need to do stuff like that. If I had my way, that's what would be going on. But that's like saying, you know, hey, just let's take checks and balances and just throw it over here. You know, it's not really how that works. Not 5%, Spartans. If you doubled their budget, they'd probably be able to get that done. How about we start exploring Venus, too? Implying there wouldn't be a follow-up mission for a Venus orbiter on an SLS, like right after that, Laz? Actually, you know what? Screw that. Screw a Venus orbiter. Manned flyby of Venus. Pick up right where the Apollo program left off. A lot of people don't know that the Apollo program was going back to, was get to the moon. And then after that, it was going back to figuring out a way to stay on the moon for a long period of time. After the moon had been figured out, the Apollo program was going to Venus, not Mars. They were going to do a manned Venus flyby. That's right, using a Skylab. Literally, that's what Skylab was for. It was designed to be a prototype Venus transfer ship. And they wouldn't circularize around Venus, they would just fly by and grav assist off of Venus and come back to Earth. That was where the Apollo program was going. It was going to Venus. A lot of people don't know that. A Skylab and what? A Nerva tug? Well, it's a slightly different version of Skylab. Here, I'll show you. It's kind of like Skylab, but it's kind of not. It's a wet workshop variant. So, here's the blueprints. Take a look. So, you have an S-4B, right? A Saturn V upper stage. The hydrogen tank is the space station. So, after they completed transvenous injection, or TVI, they would vent the tanks. And then this would work just like Skylab. And then you have your docking ring on the front. So, you'd launch it basically like a regular Saturn V. And instead of a lander right here, you have a habitation module, and then that habitation module could be extended into the hydrogen tank. That was the plan. Basically turn the S-4B into a spaceship. Like a real spaceship. Like it's called a transfer vehicle. And this is called a wet workshop. The wet workshop, basically there's an airlock at the top of the hydrogen tank here. And when they're done, they would use all the fuel going on the Venus flyby, and you wouldn't need fuel anymore, and you could, not that you could, because of that boil-off problem that we were talking about. So they would vent the tanks, and then they would have oxygen and nitrogen, a nitrox mixture that they would pump in, and they would use the nitrox mixture to evac all the liquid hydrogen and hydrogen gas out of this tank. And then the liquid oxygen tank would also be inerted with nitrogen, and they would use it as a poop tank. True story. Yes, a poop tank. That was the idea. And then this, with the Apollo spacecraft there as a lifeboat, just in case, this whole thing would fly to Venus. The Saturn V would put it on a Venus insertion trajectory, and then the Apollo spacecraft would detach, turn around, dock to the ship, and then boom, you're on a Venus flyby. And then they'd fly by Venus, they'd come back, and when they came back, it's just like Apollo. You jettison this entire thing, that thing would burn up, and the spacecraft would re-enter just like it's coming back from the moon. Smart. Pretty cool, huh? Venus flybys. That's where they wanted to go. We should do that. NASA has an upper stage for SLS that they're designing that would be really good for that. Just saying. People order our patties, Jackal. Poop. The EUS. That's right, Dark. Yep. You could do stuff like this with the EUS. It's perfect for it, believe it or not. The EUS has more characteristic energy than any other stage devised by man. What does that mean in plain English? It can go further than anything else we've ever thought of. It doesn't have the highest TWR, so it takes a little bit of time to get up to speed, but it'll get up to speed. The reason why I say get up to speed is because for the people that don't know about spaceships range is not measured in distance. Distance means nothing. It means nothing. Spacecraft's all about how fast you can go. The faster you can go, the further you can go. Simple as that. What's the EUS? Here, let me show you. EUS is the upper stage that SLS should have had from the start. This, Swishio, this is one of my gripes, about SLS, etc., etc. But check that out. This is supposed to be on top of the core stage. So that's an 8.4 meter diameter hydrogen tank and a 5 meter diameter LOX tank, and then you have 4 RL-10Cs behind it. This is like a Centaur stage on steroids. It's a big Centaur, Delta second stage. These RL-10s have 450 second specific impulse. So Okay, for people that don't understand what ISP means, these engines get like 600 miles to the gallon. Yeah, hydrogen, man. Great, super efficient. This stage could do a manned Venus flyby no problem, with an Orion on the top and then a HAB module in the universal stage adapter, this white spot. Easy peasy. That would be a very, very... The hard part would be going to Venus. The easy part would be developing the spacecraft. That would be simple. Yeah. Is it just me, or is this some reverb? They're working on this. They're trying to... NASA's trying to get this thing going right now. Artemis 4 should be the first time you see this thing come around. And if the US does come around, oh man, floodgates are going to open. All kinds of... You can do all kinds of missions with that thing. That whole carpet bombing Mars with Mars Science Laboratory rovers, yeah, you could do it with that, sure. The EOS has 45 metric tons TLI, easily. So, okay, what does that mean in plain English? 45 metric tons to a lunar orbit insertion, LOI. So, it can move 45 tons in the direction of the moon. That is in line with the Saturn V. Yeah, it can do that. Yeah, good, very good. And if we figure out that boil-off problem, it could do even more. Do you work at NASA? No, Merrick. I've worked with NASA. I've hosted panels at like TwitchCon with NASA. I'm a full-time Twitch streamer that works on STEM education. I teach people about random cool spaceflight facts. Oh, we have another telemetry update here from the mission. Yeah, MotoKit for the most part. Yeah, that's decent enough. Who told me to see the last bit? What's on your mind, dude? What is the benefit of a poop tank over ejecting it to keep the weight down? You don't need to keep any weight down, dude. You already did the transfer burn. All that mass is contained inside of that system. You already did the burn. You could just eject it overboard. That's what they did during the Apollo program. This is one of my favorite facts to say to people. Guys, the Apollo capsule did not have a toilet. And they were gone for 2 weeks. Ziploc bags. Yeah. So when I say they threw it overboard, open the hatch, put your helmet on, throw it out. I'm not kidding. That's, yeah, I know. Yeah, it kind of tainted your the glamorousness of the Apollo missions, didn't it? Sorry about that. Fun fact though, that poop is still up on the moon. Yeah, some of the Apollo astronauts poop. There is 50-year-old poop up on the moon. True story. You're welcome. That's probably why I don't work for NASA. What I just told you right there. Yeah, that's probably why. 96 bags to be exact. Thank you, Thomas. Like special, yeah, space Ziploc bags. Space Ziploc. Yep. What? Why no bathroom? Why no bathrooms? Wait. Because Ziploc bags weigh a lot less, Clayton, than a damn toilet. The same exact reason why if you're going on a road trip, you don't stop to go to the bathroom, you pee in a bottle. It's the same reason, dude. It's more efficient. I'm not kidding. Like, I'm sorry. Like, they couldn't... what the hell? They didn't have time. They didn't have time to put a toilet in there. Humans pooping on everything. Wait, what? The worst part is we cannot burn the poop away because it's in space. Yeah. The bottle. I'll find a tree, thank you very much. Yeah, but that's very inefficient because you have to stop the car. Shame. Shame. Alright, guys. I hope you enjoyed the European Space Agency's Galileo launch. Aren't you supposed to open the sunroof and stand up and drive 90? Yes, sure. Pee out the sunroof. Some men just want to watch the world burn. Depends. I see what you did there. The design of Apollo was so crazy. I listened to about maybe a quarter of Apollo and hearing out all the arguing back and forth about the designs. It was tough, man. It's tough to get it right, Evil Bit, but they did it, which is crazy to me, dude. And they did it in 10 years, which is even crazier. And nobody had ever done it before. It's pretty damn impressive, dude. Was not having a toilet on purpose. Yes, EMH. They didn't have the weight. Okay, so in spaceflight, mass has a lot to do with it. Okay? A car analogy is easier to understand, so I'll go with that. If you're carrying 100 pounds of weight and the range on the fuel tank, if you have 100 pounds of cargo in your car and the range on your fuel tank is 1,000 miles, right? And your destination is 1,200 miles away, what do? Now, in real life, we can stop at a gas station, right? It's not a big deal. You stop at a petrol station, it's no problem. They don't have that in space yet. So you either get to your destination with enough fuel or you figure out something else. So if you're moving 100 pounds of cargo, what do? You take the seats in the car and you throw them out to save some weight. Spacecraft work like that. There's no gas station out there, man. You can't refuel. We haven't figured that out yet. It's going to happen. We'll figure it out. That's like saying, in the 1950s that commercial airline travel won't be a thing. We'll figure it out. Oh yeah, we'll figure it out. No, the NASA engineers just forgot about that. Yeah, the slide rules, baby. Slide rules are cool, Evil Bit. I want one. So have you experienced oscillations in your steering linkage when putting medium to heavy lateral load on your driver's side tire? Trucks, Sawyer? Wait, hold on. Have you experienced oscillations in your steering linkage when putting medium to heavy lateral load on the driver's side tire? No. No, never. The only time I really had really bad oscillations is when the wheel was about to fall off. Yeah. Other than that, truck drives straight as a die. Straight down the road. I mean, the suspension is a little floaty, but it's truck suspension. What do you want? It's twin I-beam. Of course it's floaty. Okay, because mine does that sometimes. I think Evil Bit is right. It sounds like your alignment's off. Or you have your tie rod bushing is shot. Not tie rod bushing, you're just the tie rod. Good evening. So the other day started Lovell's Lost Moon Apollo 13. Jury's still out on it, but it's still very interesting, the perspective of their side. Celtic, I'm not familiar. I'm thinking if the EUS, if it's Centaur on steroids, Centaur Killer, we should call it Killatar. I like that. It's a good idea. In the Stargate universe, they had a ship that harvested fuel by flying through the outskirts of suns. Yeah, Maslam, that's a real concept. It's called the Bissard Ramjet. It uses solar ionic radiation as an oxidizer. It's really cool idea, actually. Yeah, Bissard Ramjet. B-U-S-S-A-R-D. Yeah, Nikita, that's the other thing. Yeah, you could have mud in the tires. Could have mud in the tires. Nah, that's a figure of speech. That's been in sci-fi going back decades. It was in a sci-fi book I read from 1974. Yeah, if there's any newer viewers in here, we're also a bunch of sci-fi nutcases. If you want to discuss science fiction, we can discuss the finer points of a warp drive versus hyperspace versus the Sha Fujikawa translate engine. Okay? If you want to discuss the finer points between faster than light drives from different sci-fi universes, we can do that. Or we could go the 40K route and talk about the warp, and everybody will go insane from being stuck in the warp for 5 seconds. If we want to do that, we can do that too. Hello?
Hi.
Hi, Brimo. Brimo's here.
Hi, new viewers. I'm Brimo. I'm the fiance. I just wanted you to know that for racing tonight.
Okay, that's fine. See, they're doing it.
They're doing it again.
They're doing it again.
Did you tell them what I said?
Yes. No.
Oh, okay. Because
the reaction was not a preferable one. 95. Whitney says hi.
Hi, Space Explorer. No, you didn't. So you didn't tell them exactly what I said. You just said it's not favorable.
It's not a favorable outcome. It wouldn't have been a favorable outcome. Let me put it to you like that.
What I told him is that if I say it to him as an explanation, it's okay. If he says to me, no, that's when you die.
See? Not a favorable outcome, I told you. I mean, that's not... We had a scientific hypothesis, and we proved it scientifically. You were the control group.
Yeah.
Well,
I mean, I'm only a sample size of 1, so...
I think enough viewers in the chat can weigh in that this is... We could probably get a wider sample size, but I don't think that's a good idea. Wear a cup.
I love you.
Love you too.
Mwah! Alright, bye.
See you, Bray. Yeah, Wendy. No, I made sure that I phrased it in a way to let Brimo know it was a scientific control. It was an experiment. It was more of an explanation after the fact, but hey, what? It still worked. It still worked. We are in one piece and still alive. This is not a recording. It is 8:37 p.m. on December 4th, 2021, right now. See? Not a recording. Unless this was recorded and Brimo came in at a predetermined time just for me to say this on time. Oh, crap. Help me. Help me. Help! Help! She's gone crazy. Oh, no. Blink 3 times. What if she predicted that, too? All right. Oh, God. All right. Here, let me see. Do we still have updated telemetry? Yep. Slap myself. Okay. You're not a recording, but Chet is.